When I was learning PTSD and how it appeared in the brain, a lot of the early studies, you can see around year 2000, talked about how trauma will cut the corpus callosum, will cut the connection between the right hemisphere and the left hemisphere. Left hemisphere, if you're typically organized, left hemisphere is the one that deals with familiar stuff. It's the one that you feel in charge. The right hemisphere is more for novelty, which can be good, but it can also be a sign of, when novelty is a sign of danger. It's a sign of something you don't know what's going to happen. So the argument is that the two hemispheres are losing their coordination. So you're not able to quickly take novelty and make it feel familiar, which means you're staying in the danger mode. Plus, the argument is that the right hemisphere is getting more in charge than it should be. And so you're constantly overreacting to things that you should be calm to, calm to things that we're familiar with. Well, again, the thing about looking for any kind of anxiety problem or stress disorder, how you respond to stress, is how do you individually, uniquely respond to stress. These studies are all great, looking at scientific literature, but we can look at the brain map to figure out how the person is organized, where the immature habits are coming through, and tap those habits, improve those habits, train the habits out of there. This is an example of I think this is an impulsive individual who has some issues going on here in terms of orbital funnel guidance and hierarchy in Broca's area. Orbital funnel is how you respond to your appetite. The orbital funnel controls your appetite. So over-responding to stimuli of things you like, if it's be it a video game, sugar, food, ice cream, beer. In this case, as a kid, it was more like video games and so forth. You can see how this green is normal. We don't want yellow in this map. We don't want blue's okay. We have to figure out what's going on in blue. We refer it towards the green. Think of green as this balance point. And you can see how the yellow is what we want to get out of there. Now most of our remaps, and this is an example, is not at the end of the treatment. This is all used for the individual. We're training the individual. So that's, in essence, a mid-map, or it's near the end, but we still got about 10, 20 hours of training more to do. It lets this mid-map, 30 hours post DNT, default network training, lets us know, okay, now we got to continue to work on that left auditory cortex and maybe a little bit on the right dorsolateral. And we look at the areas in the other parts of the map, which is, I'm going to show you because this case is coming up. Okay. All right. So we had an individual recently, not that recently, a couple of years ago, who responded to stress by becoming obsessive. It's not unusual. It's kind of like some people become obsessive and try to control everything. Other people go impulsive. And then a third, you could say, just decide to drink or have substances to control their response to stress, to chill them out. And OCD has been around. We've known it since Shakespeare's time, probably well before then. There's Lady Macbeth from a Shakespeare production, showing still believing she has blood on her hands from a murder and having to constantly wash her hands. Obsession, so she had OCD, and that's 400 years ago, talking about OCD. So obsessions are repeated thoughts, compulsions are repeated behaviors. You think of being obsessed about germs, terrible events, keeping things all symmetrical and orderly. And now with COVID being, it's a germ problem, virus problem. Compulsion is about grooming and checking, your stoves and your locks and appliances, make sure they're turned off all the time, and other forms of compulsion. All right, this is an old map. This is, again, probably 40 years old. I think it comes from UCLA medical school. You can see when someone's obsessive, more blood flow in that frontal lobe. Now, the frontal lobe in that location, decision-making areas. Probably interior singlets involved, probably area 10, looks like maybe 9. And more activation than is necessary. This has been controlled, same condition. Probably was, looking at the normal, it wasn't a condition that required much brain activity, but the OCD individual suffering from OCD is overactivating. Now, the one thing with depression, we always have to worry about suicide. Suicide is highly related to when people get depressed, and you can see the suicide rate. They start kicking in adolescence. You can see 5-year-old kids, 5 to 14, not worried about suicide. We actually have a case I'm going to show you coming up, a 6-year-old talking about suicide, and it peaks around this age, in your when you should be most productive and having enough for your family, and it drops actually. You feel more and then it peaks again as you get older, as life gets harder, extremely hard. The suicide rate continues to rise. It's been increasing. Now it's up to 13 suicides per 100,000. It's 48,000 suicides in 2018, about 45,000 a year. I think that's the same number of people killed in automobile accidents. It's twice the homicide rate. 7th leading cause of death in men, 14th in women, but look at that other one, 2nd most leading cause in teens. Females attempted more, but males succeed. This just shows you how the suicide versus homicide. People always think about how dangerous society is, and here the U.S. is in here in the middle, right here in this group where you have more suicides than you have homicides. So here's the 13s here, but the homicides are more like, it's like around 7 or 8 per 100,000. Here's the more violent societies. Greenland was off the chart in terms of suicides, probably because of the isolation, which is unfortunately we're all getting isolated through the COVID crisis now. This is showing the sharp rise in the last 20 years. And you can see it's actually, the rise is highest up here in where there's more space for people. A little bit in New England, a little bit South Carolina, but more space. It's interesting to have such a rise. Okay, now we actually have a marker we see often associated with self-harm and suicidality. It's actually area 5L on most people, but I box both 5R and 5L because you got to think of the network. They're governing each other, so if 5L is messed up, or 5R is messed up, it could be messing up 5L as well because it's not governing it well. But usually it's 5L is the worst, but you can see sometimes it's very much a bilateral. And the one thing you see in depression, so we have a marker there, and the one thing you often will see is, and this is the person who actually committed suicide, they actually follow through with it, is that people go through who are bipolar, showing the bipolar, because they have the rise and the fall in their cycles. Depressed unipolar just have the fall, is you're most likely to commit suicide or attempt suicide, I should say, not when you're in your manic episode. That's when everything's great. Not when you're sort of dropping. It's not in the trough. It's not when you're at your deep. It's when you start coming up and start feeling good again, when you feel like you have energy again. Some people think it's the reason why you see more suicides on the rise as people are coming out of a deep depression is because they planned to kill themselves to end all their problems, and that's why they're now happier. But also, you don't have the energy when you're in 3. You don't have the ability to do much. And once you have a little bit of ability, that's when it seems to happen the most. Okay, so here's a bunch of kids, one adult. Area 5. 5L showed up early on. We knew 5R was actually usually it's outward aggression. 5L then is inward aggression. And so we see self-harm, we see cutting. Here's a girl, for instance, who's cutting, talks about suicide. Here's a 6-year-old talks about suicide. You can see it's more strong on the left side. It just happened in that case. But again, you want to kind of look at they're called homologs, these pairs, as if they're similar. And that's because they govern each other. So he's 45 who committed suicide. He's 12-year-old talking about it. Otherwise, very healthy. This person was healthy. And what we do is we target these areas with the default network training to normalize that behavior. Get them from out of the orange to into the green. Orange means it's functionally transparent. It's letting the subcortex through, not letting the neocortex is not in charge. And here's an example of the neuroimaging associated with PTSD. It's the here the posterior cingulate and the precuneus coordinating together. There's all kinds of there's other neuroimaging markers. We see this functional neuroimaging marker of the PCCs showing immaturity. This is functional transparency. When it's orange, it's letting the subcortex, it's showing the same theta in all directions. Letting the subcortex, in essence, their impulses drive the show. When it's blue, it's like opaque. It's blocking, it's over-blocking the subcortical impulses, and we want to get that green point where it's a balance. So how do we find out who's orange or blue in which brain areas? Well, we start off by recording 19 areas of your head, doing conditions that we've well studied, eyes closed and eyes open resting states. And we compare you to a goal group, convert the data down to what I call the Brahman montage, which lets us see the activity in the regions. We also can convert it down to the areas. And there's a reason why we don't use, it's an inverse solution, the Brahmin montage, but it's a superior solution to those who try to go down to voxels, a single voxel, and say, okay, we're going to do every voxel, 2,000, 3,000 voxels in the head, and know what's going on in each signal point, because each person's brain is differently organized. So like this just happens to show, this is a study that shows how in 10 individuals, the red point is the only voxels that are in area 17 in across the 10 people. So if you're in a voxel out here and you think you're still in 17, in some individuals you are, most individuals you're not. So you can't, going down to the voxels to figure out how the signals are generated is too strong a technique, and it's going to be inaccurate. I'll give you another analogy. It's like if I decide to figure out if you're a baseball fan, and I use my criteria that you have to be in the stands right now to be a baseball fan. If you're not in the stands, you're not. Well, obviously that's too strong a criteria. Most people will be judged as not a baseball fan who are. But how about this? I would say, okay, because I'm from New England and a lot of people follow the Red Sox. If you're from New England, you're a baseball fan. Well, that's too loose a criteria. And science is all about finding the criteria that best fits. It's kind of the middle ground of what will really capture who is a baseball fan or not. Well, it might be, for instance, have you been to a ballpark, or have you watched a game of baseball in the last, not counting this crisis, let's say in the last 2 years, have you watched more than 3 games, or even just one game might be good enough to call you a baseball fan. Again, you create your criteria, and the problem with doing the voxel inverse solution that you see other brain mapping software does, it's too rigid. What we use is a technique that picks up, and the reason why the validation that it's a better technique is that we have all these neuromarkers that show, okay, that person's going to have self-harming tendencies. This person's going to have maybe show behavior that's consistent with PTSD, and we improve those areas, and then those behaviors improve in their symptoms. Okay. We compare people to, again, also a lot of people in the other brain mapping software, they compare people to an unhealthy group, in essence. People came into the hospital to get an EEG, or they got, a bunch of people. I chose the people who are in this database. They are the healthiest people. I cut out about 100 people when I made this database, because I had to get the best ones. What I thought were the highest functioning. They're all college educated, half have graduate school degrees. They are the guardian angels of my life, in essence. Compared to unhealthy groups that most people grab this nondescript, we just want to bring in high numbers. Bring in high numbers, the quality control is lost, and usually it's going to be lower functioning. So when you train people to those lower norms, what are you doing? You want to train people to the higher group, the goal group norms. Okay, so this just shows you the reliability of theta unity. In fact, a lot of people, when they do a brain map, will do EEG is very sensitive to the state you're in. If you're fatigued or activated, or whatever's going on. And the EEG is very good for states, but you got to find the EEG measures that reflects traits, reflects habits. And I did a lot of this work over the 30 years, found out there's all kinds of state parameters, ones that have a lot of state elements, but there's not so many that have trait elements. And theta unity seems to be the best one. And this is an example. You're looking at 6 replications, 3 eyes closed, 2 eyes open. So they're actually doing slightly different things. How that person's brain looks. That's not unusual to see how consistent it is. It really picks up habits very well. And the one thing with neuromarkers, it again isn't like a death sentence. If you have that marker, for one, it's not a death sentence because we can improve it, we can fix it, we can with default network training, we can remove the problem, the immaturity in there, remove that transparency, get the gray matter, white matter in those locations that need it. But also, you may have that marker and not be full blown show the behavior of the syndromes associated with that marker. So it's sensitive but not specific. But it's sensitive, so let's go ahead and fix it. And that's, it may not show up. And as like if you have that's usually a PTSD marker. You may not have PTSD, but it may be closed. Okay,